In modern aquaculture, unstable water quality, elevated disease risk, and heavy dependence on medication remain shared challenges worldwide. To address these issues, new approaches are being explored, combining biological balance with physical water optimization, rather than relying solely on chemical intervention. This video takes you inside the laboratory of Dr. Su Feng-Jie at National Kaohsiung University of Science and Technology, Taiwan, where an innovative integrated system is being studied. You will discover how he combines probiotics, HKE ResonanceTechnology, RAS seawater recirculation systems. In addition to cultivating Haematococcus Pluvialis, Dr. Su Feng-Jie also used Malaysian sea cucumbers and tiger grouper fry as indicator species to evaluate whether the treated water environment could provide benefits for fish and other marine organisms under RAS conditions. Professor Su applies Aquahex HKE physical resonance technology by placing multiple titanium plates inside the RAS recirculating seawater loop. As seawater flows continuously through the system, resonance is generated throughout the water body, creating the following characteristics: more stable dissolved oxygen, reduced pH fluctuations, smaller and more energetic water clusters, faster activation and proliferation of probiotics. These changes build a more stable, more probiotic-friendly, and lower-risk environment for the entire RAS system. Under the influence of HKE resonance, both the concentration and stability of dissolved oxygen increased significantly, while pH remained within the narrow range suitable for microalgae and marine fish. For example, Haematococcus Pluvialis grows best at pH 7-9. With HKE resonance, the RAS system maintains this optimal range long-term, laying a strong foundation for subsequent cultivation. Using his self-developed NKUST1 culture medium, Professor Su studied the growth curve, light intensity, temperature, pH, and Astaxanthin accumulation of Haematococcus Pluvialis. According to the experimental results, growth rates surpassed F2 and WALN media starting from day 5. The effects of 3 culture media, NKUST1, F2, and WALN medium, on the growth of Haematococcus Pluvialis are shown. From day 5 onward, growth in NKUST1 was consistently higher than that in F2 and WALN medium. pH changes of Haematococcus Pluvialis under different culture media. All 3 culture media were able to maintain the pH value at approximately 7. Optimal performance occurred at pH 7 to 9. Astaxanthin accumulation steadily increased, peak at 471.7 nanometers. The carbon fixation efficiency of non-reddened Haematococcus Pluvialis is 135 ppm per hour, while that of reddened Haematococcus Pluvialis is 70 ppm per hour. Approximately 1 liter of Haematococcus Pluvialis culture can absorb about 1.83 kilograms of Co. These results demonstrate that Haematococcus Pluvialis shows higher activity and greater value when grown in a water environment stabilized by resonance. This aligns with the 4 major goals of the research: improve cultivation efficiency and production scale, enhance Astaxanthin synthesis and accumulation, achieve carbon-negative benefits and sustainable aquaculture, promote commercialization and market applications. The experiment also tested Malaysian imported sea cucumbers. 1 batch was sent to one of the marine research stations. All individuals died. The other batch remained in the MCUST RAS system, with HKE resonance plus probiotics, where the mortality rate was only 5%, and those deaths were due to transportation stress. Identical sea cucumbers, identical probiotics, but only in the RAS system with stable dissolved oxygen and balanced pH were they able to survive and grow healthily. HKE resonance became the key differentiating factor. Professor Su also obtained tiger grouper fry from a local aquaculture farmer and divided them into 2 groups. Experimental group, HKE resonance technology and probiotics. Control group, probiotics only. After 3 months, the results were astonishing. Experimental group, active behavior, strong feeding response, fast growth, and high feed conversion efficiency. Control group, very low survival rate, with only a few fish remaining. Professor Su explains that probiotics are aerobic organisms. They thrive in oxygen-rich water. HKE resonance maintains high, stable dissolved oxygen, enabling probiotics to perform at their maximum potential. This improves digestive function, strengthens immunity, and reduces disease risk. If you're interested in HKE resonance technology, microalgae cultivation, or RAS applications, feel free to leave a comment below. We will continue sharing more research insights.